All right, good afternoon, everyone. Sorry for the delay. But before we start, just a reminder, problem set number 3 was live in Canvas yesterday. So I hope you guys already saw it or downloaded it. Tingnan niyo siya dun sa modules part. I think it was module number 6. Nandun yung PDF file containing all the problems in the problem set. And then ang instruction ay may tatlong parts yung problem set. Number 1 is the essay part. Part B is, I think that's the deepening part. And then part C is the synthesis part. So kailangan sa bawat isang part na yon meron kayong isang sasagutan. So problem number 1 is required kasi siya lang yung essay problem. Then you can choose from problems 2 and 3. Isa lang yung sasagutan nyo doon. Tapos sa part C, you can choose between problems 4 and 5. So there will be a total of 3 problems that you will submit. So tingnan nyo na lang kay Canvas yung appropriate submission bins. Okay? And the deadline is, when is the deadline? The deadline is on November 29th. That's this coming Monday, right before midnight. So probably we can discuss a little bit about it if you have some questions, clarifications, or some requests pagkatapos na lang ng discussion natin for today. Because today I think we can finish this unit. Napakaiksi lang talaga nung ide-dedicate natin sa derivatives because probably we'll focus more on integrals. Okay? Kasi nga napaka-restrictive ng konsepto ng derivative. So the results from here are very well structured. So kasi nga bago ka maging differentiable, napakalaki ng requirement. Okay? So hindi sufficient na pag continuous ka, ibig sabihin differentiable ka na. So graphically speaking, a continuous function is a function that you can draw without lifting your pen if your interval of consideration, if your set of consideration is an interval. However, sa differentiability, hindi lamang continuity yung requirement. Merong mga continuous function na hindi differentiable. So dapat smooth yung graph. So that means there should be no sharp turns, there should be no cusps, and there should be no points of discontinuity. Because we know that if a function is discontinuous, it is automatically not differentiable on the given interval. All right? Now, last time we looked at the definition of the derivative and some of the major theorems about derivatives. Number one, you have the algebraic theorems for derivatives. You have your sum and difference rules, the product rule, and the quotient rule. At kung mapapansin nyo, yung mga proofs nila ay involving lang isang clever manipulation ng function na kukunan natin ng derivative. So nag-add and subtract tayo ng isang quantity or ng dalawang quantities na nagka-cancel out to zero, or we multiply whatever we are dealt with the quantity equal to 1 so that we will get the required form as in the definition of the derivative. Kasi yung definition ng derivative, limit siya ng difference quotient as the increment in the denominator approaches 0. Okay? Now we also look at some named theorems. Most notably, we look at Fermat's theorem, which says that if your function attains a maximum or a minimum at a particular point on your interval AB, then that means the derivative at that point must be equal to 0. And that's the basis kung bakit sa optimization sa Math 36 ay kinukuha natin yung critical numbers. Kasi alam natin ang tanging candidates para magbigay sa atin ng absolute maximum or absolute minimum on an interval would be those critical points or the points wherein the derivative has 0 value. Ganun din siguro for those who are in the applied math program sa inyo and kung nag-optimization na kayo, necessary condition na maging 0 yung derivative sa isang optimizer o isang maximizer or minimizer sa isang function. And that's thanks to, in part, to Fermat's theorem. Then we also look at Darboux's theorem, okay, which is basically the analog of the intermediate value theorem for derivatives. So kahit hindi natin sure na continuous si f prime, meron din siyang intermediate value property kasi nga mas strong yung condition ng differentiability. So even though we are not sure if f prime is continuous, ang alam natin ay meron pa ring number na dun sa interval that can take as function value in the derivative ang kahit anong intermediate value between f prime of a and f prime of b. Okay. I hope you can remember these theorems because in our next problem set, which would be around the end of the semester, I'll probably ask you to apply these theorems either to prove some results or to apply this to certain functions. So yun yung magiging part ng problem set. So today we'll finish off the lecture notes with some major theorems. I think we'll have three major theorems here. Tatlo nga ba? I think three or four. And that will begin with Rolls Theorem. Okay? And tinuturo to sa Math 36, no? Nakita niyo na rin tong Rolls Theorem from your elementary calculus classes. Tama ba? Yeah, I think so. So Rolls Theorem, let's see what it is. So for Rolls Theorem, we consider a function defined in a closed interval AB, all right? And we assume that f is continuous on the closed interval Z and differentiable on the open. And it says here that if f of A is equal to f of B, then there exists a number C strictly between A and B such that f prime of C equals 0. So kung continuous yung function sa closed interval at differentiable siya, tapos equal yung function value dun sa dalawang endpoints, then there will exist a number where the derivative is equal to 0. So graphically speaking, okay, pwede mo yung i-drawing ng ganito. So kuha tayo ng interval AB. Tapos sabi raw dapat yung function natin ay continuous dun sa closed interval AB tapos differentiable dun sa open. Tapos ang f of A ay equal kay f of B. Alright? So equal sila, may common value sila. Sabihin natin common value nila ay si capital M. Alright? And then it should be smooth and continuous over the interval. So say, eto siya. Okay, of course, this can work with some crazily oscillating function as long as the oscillations are smooth. All right? Ang sinasabi niya lang ay laging merong number doon sa interval AB kung saan ang derivative ay equal to 0. But looking at the definition of the derivative, slope lamang siya ng isang line. In particular, it is the slope of the tangent line at a particular point. So you can take a look at the curve and see kailan siya nagiging horizontal yung tangent line. Kasi kung ang derivative ay slope ng tangent line, tapos kung yung slope na yun ay equal kay 0, so therefore, dapat makakahanap tayo ng point kung saan horizontal line yung tangent line. Or you can look at it in another way, but using Fermat's criterion or Fermat's theorem, na sabi niya ay kapag ka nag-zero yung derivative, ibig sabihin okay, hello guys. I hope I'm back. Sorry, naputol ako bigla. I don't know why. Perhaps my connection was down. Pero you can hear me now. Can you hear me now?
Yes po.
Okay, thank you, Ray. Yeah. So, as I was saying, hindi sinasabi ni Rolls Theorem kung ilan yung mga numbers C na yon. All right? So, in particular here in my example, I also see a dip here, dun sa function value, or dito nag-occur yung minimum, right? Or yung absolute minimum or relative minimum. So in this particular point, again, appealing to Fermat's theorem, yung derivative dito ay equal rin kay 0. But if you are more graphical or visual, so maiisip nyo, doon yung tangent line ay horizontal, so this must be another value of C promised by Rolls Theorem. Okay? Now let's prove Rolls Theorem. Actually, the proof is quite simple. Okay? So actually, maganda naman yung pagkaka-state ng proof dito. So, all right, so we have two cases to consider. So f is continuous on the closed interval AB, then ang sabi ng extreme value theorem, okay? Kung meron kang function na continuous sa compact set, then ma-achieve niya yung maximum at saka minimum doon sa compact set na yon. Yun yung extreme value theorem natin o yung Weierstrass theorem, okay? Since f is known to be continuous on the closed interval AB, and the closed interval AB is compact, then f will have a minimum and maximum value on the closed interval AB. So yun yung pangako ng EVT. All right? So may dalawang cases. Number one, the maximum and minimum values occur at the endpoints or they don't. Okay, so yun yung dalawang cases. First case, kapag yung maximum at saka minimum values ay doon nag-occur sa endpoints, either kay A at saka kay B, all right? So ibig sabihin, ito ay end yung ginamit. So yung maximum at minimum values ay nag-occur sa A at saka si B. So ibig sabihin parehas maximum at minimum si f of A at saka si f of B, whatever combination they might take. Pero may assumption nga pala sa Rolls Theorem that f of A must be equal to f of B. So if the maximum and the minimum will both occur at the endpoints, ang function value dun sa dalawang endpoints ay equal sa isa't isa. So therefore, ang magiging itsura ng graph natin dun sa case 1, okay, A, B, si A daw yung highest, si B ay yung lowest, pero equal silang dalawa, all right? And these are the maximum and minimum values over the interval AB. So we don't have a choice, but the graph of f on the interval should be a horizontal line. Okay? Kasi pag meron diyang isang point, halimbawa may isang point dito, hindi na nag-occur yung minimum doon sa endpoint. So hindi pwedeng ganito yung itsura ng graph natin para kay f. Kasi mababiolate niya yung assumption ng case 1 na yung maximum at minimum ay parehas na kay A or na kay B. Okay? So there's no way on how to draw a continuous function whose maximum and minimum occur at the same value and at the endpoints, other than drawing it as a straight line. Okay? So dun sa case 1 na nag-occur yung maximum at minimum sa magkabilang dulo ng endpoints, we are resolved that the function is or has a horizontal line as its graph. At dahil horizontal yung graph niya, ibig sabihin constant function lang pala si f dun sa interval AB. And if you compute the derivative of a constant function, it will just be equal to 0. Okay? So that means, dahil constant function siya, ang derivative ng constant sa buong interval ay 0, so f prime of x will become 0 not only at the point in the open interval AB, but all throughout the open interval AB. Okay? So, and obvious lang naman siya, obvious siya kung graphical yung pag-iisip nyo. So, straight line or straight horizontal line yung graph. So, ibig sabihin yung horizontal, yung tangent line sa buong interval AB ay horizontal din. So, we have found infinitely many values of C on the open interval AB. All right? So, the more interesting case is the second case. What if the maximum or the minimum value occur at some point C in the open interval AB? Okay, so ibig sabihin, hindi parehas nag-occur yung max at saka minimum dun sa magkabilang dulo. Kunwari, sakop ng case number 2, yung pwedeng maximum ay nandun sa magkabilang dulo, pero yung minimum ay nasa isang point other than the endpoints. So pwedeng ganito yung itsura ng graph. Okay, A, B, posibleng nandito yung maximum, pero yung minimum dapat pala smooth, no? Walang sudden turn. Pero yung minimum nag-occur in a point other than the endpoints. Or pwede rin naman na maximum yung nag-occur sa isang point outside that interval, outside the endpoint. So pwedeng ganito rin yung itsura ng graph. Okay? Yung maximum niya nag-occur doon um, sa 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 interior ng interval. Okay? Or pwede rin naman na yung may maximum at saka minimum doon sa interior ng open interval. Pwedeng nandito yung maximum, pwedeng nandito yung minimum. Okay? Posibleng ganito yung itsura ng graph. So they are covered in the second case kasi ang connective ay or. But actually that is also easy because if there is a maximum or minimum at an interior point of the interval AB, then by Fermat's theorem, we know that the value of the derivative at that number C must be equal to 0. And hence we have illustrated na meron nag-exist na the value dun sa open interval kung saan ang derivative ay 0. Okay? And that completes the proof of Rolls Theorem. Okay, is that good, guys? Medyo napahaba yung explanation, no? Pero I hope you appreciate how the proof went. Okay? Now, the Rolls Theorem is a very important part in the proof of the mean value theorem. And actually, the mean value theorem, which is theorem 4.7 here, can be thought of as the generic case or the generalization of Rolls Theorem. Kasi kung papansin niyo dito, parehas sila ng assumption. F is a continuous function on the closed interval and it is differentiable on the open. Ano lang ang nawala? Nawala lang yung condition na si f of A ay equal kay f of B. Pero kung ipapasok ko uli yung condition na yon na f of A equals f of B, then the numerator here will become 0. So f prime of C equals 0, same conclusion. Okay? Pero ito mas generic. Wala yung requirement na si f of A ay equal kay f of B. And it says here that if that happens, then we can find a number C on the open interval AB such that f prime of C is equal to this guy. Okay? And this guy is usually called the mean value of f. Okay? Kasi siya yung difference between f of A and f of B divided by the length of the interval. Okay? So yung quotient, yan yung tinatawag natin na mean value. Then how do you think this will look graphically? Ano yung kung visual kayo mag-isip, ano yung ibig sabihin ng mean value theorem? So alam na natin analytically at yung sinasabi niya, may mahanap tayo na C dun sa open interval na ang value ng derivative ay ito. But what is the geometric interpretation of this one? Any idea? Sa Rolls Theorem, laging merong isang point dun sa open interval o dun sa interior ng closed interval kung saan horizontal. So in that same vein, how will I interpret the mean value theorem? Sige nga, any volunteer? Oh guys, volunteer kayo kasi sayang yung points sa problem set. Kung nakita niyo na yung problem set, baka alarmed na kayo. So kailangan niyo mag-ipon ng extra points para sa problem set. Anyone? How will I interpret it? So A, B. Walang gusto mag-try? Sige, bahala kayo. Sayang yung extra credits sa problem set. Okay, so if no one would like to try, then I'll give you my geometric interpretation for it. Hindi lang akin, pero sa lahat ito yung geometric interpretation. Now, your function is continuous on the closed and differentiable on the open. So same thing as Rolls Theorem. Na wala lang yung condition na yung f of A ay equal kay f of B. Okay? So that means I can draw the graph of f to be something like this. All right? Or it could be a crazy looking function as long as there are no gaps or there are no sharp turns or cusps in the graph. Okay? Tapos ang sinasabi niya ay, okay, f prime of c. Ito yung slope ng tangent line at the number c. Okay? But how about this guy? How will you interpret this? Sige nga. Yun na lang. How can I interpret this value? Or what's the interpretation for this value? Oops. Baba ko. I hope you will agree that this is nothing more but the slope of the line passing through a comma f of a and b comma f of a. Because this is the change in the y values. So those are your rise. Tapos ito naman yung b minus a. Ito naman yung change in x. Ito yung run. So you have rise over run. So basically, this is the slope of the line passing through a f of a and b f of b. So if you look at that graphically, then that quantity, the mean value of the function f on the interval a, b, is basically the slope of this line. Kunin ko yung line na nagpa-pass through kay f of a at saka kay f of b. Alright? Yung slope nitong orange line na to, yun yung tinatawag natin na mean value. Alright? And then the mean value theorem states that I can find, a point on the open interval whose slope mean value. Therefore, that tangent line will be parallel to the secant line passing through a f of a and b f of b. So in my search for c, hanapin ko lang ano yung line o saan yung point na parallel yung tangent line dun sa secant line passing through the endpoint. So, hanapin ko lang. Oh, there you go. So, the tangent line here is parallel to the secant line passing through the endpoint. So, this is the value of c promised by the mean value theorem. And again, as like in Rolls Theorem, walang sinabi si mean value theorem kung ilan yung nakakasatisfy nun. So pwede pa akong humanap, and true enough here, the tangent line here is also parallel to the secant line. So that means this is also one of the values C's promised by the mean value theorem. Okay? So yun yung geometric interpretation ng mean value theorem. Very similar to Rolls Theorem, except na hindi na a horizontal line yung hinahanap natin to be the tangent line on the open interval. Okay? Now, with this very close relation between Rolls Theorem and the mean value theorem, the proof of the mean value theorem will take advantage of the result from Rolls Theorem. So ang gagawin lang natin, we will define a nice function on which we will apply the Rolls Theorem. Tapos makikita natin na, okay, talagang may nag-exist na number c dun sa open interval such that f prime of c is equal to 0. Okay? And let's look how the textbook did it. Actually, it was done in a clever way. Nag-define siya ng isang auxiliary function d. Okay? Tingnan natin. Na-satisfy na nung kasi parehas ng assumption, yung mean value theorem saka Rolls theorem, except na para ma-apply ko si Rolls theorem, kailangan kong magkaroon ng isang function na equal yung function value sa magkabilang dulo. Yung function f na given sa MVT ay wala nung property na yon. Hindi natin sure na si f of a ay equal kay f of b. So hindi ko ma-apply kagad. Okay? Pero I can manipulate it a little bit. Okay? Makita nyo dun sa proof kung ano yung ginawa para ma-force yung issue na mag-apply si Rolls Theorem, and at the same time, I'm gonna get this conclusion. Okay? How was it constructed? Well, we considered the line passing through the endpoints. So ito yung drawing natin kanina. Parang kinuha ko yung secant line. And the equation of that line is given by this guy. This is just the two-point form of the line applied. And you see that this is actually the slope. And this is the intercept. All right. And then we will define an intermediate function. Tawagin natin siyang d of x. Si d of x ay ginawa kong function na to. Alright? So basically, this is the line passing through the endpoints. Tapos ito yung arbitrary function f na binigay dun sa theorem. Okay? Bakit natin pinili itong function na ito? Okay? So we chose this function because d is still differentiable on the open interval and it is still continuous on the closed interval. Bakit? Kasi si f ay continuous. Ito ay isang linear function which is also continuous. Continuous minus continuous will give me a continuous function. This is differentiable. This is a linear function, so it's also differentiable. Differentiable minus differentiable will give us another differentiable function. Okay? So, differentiable pa rin siya. So, nasa-satisfy ni D yung premises ng Rolls Theorem. Okay? Or actually, hindi pa pala tayo sure. Pero yung main requirement ng Rolls Theorem, na-satisfy niya na, except possibly, yung pagiging equal ng magkabilang endpoints. Okay, let's see if that is satisfied. Plug in A. If we plug in A, let's look at D of A. So D of A, so lahat ng X, mapapalitan ng A. So this guy will go to 0 kasi meron kang A minus A. So matitira lang dito sa naka-bracket ay F of A. F of A minus F of A, that will be 0. So D of A is equal to 0. Okay? Now, if we plug in B, ano naman yung mangyayari? Computein natin yung D of B, and then this would be B, and then what will happen? Oh, B minus A will be canceled by B minus A, then this would be negative F of A plus F of A, so they will cancel each other out. Then F of B minus F of B, that will also be 0. Okay? So ang D of B rin pala ay equal kay 0. So therefore, D of A is equal to D of B. So therefore, the function D satisfies all the requirements of Rolls theorem. So therefore, we can find a number C on the O such that D prime of C is equal to 0. Okay? At dito na papasok yung beauty ng pagkakapili kay function D. Alright? Because sabi ay merong D prime equals 0. Okay? Pero pag kinompute ko yung derivative ni D, so I will get f prime minus the derivative of this guy. But the derivative of this guy is just the slope of the tangent line, right? But that is basically this guy lang naman. Or pwedeng gamitin nyo yung algebraic theorems para ma-differentiate ito. And you will see that that is equal to f of b minus f of a all over b minus a. Pero we have said that at the number c, on the open interval AB, the derivative is equal to 0. So if we plug in C into D prime, we will get the number 0. Okay? Plugging C into the left side, into the right-hand side, we're going to get this one. Okay? So this one will be equal to 0. Perform some algebra. You will be able to see, actually, isa lang pala yung kailangan gawin. So naka-equate to kay 0. Kailangan nyo lang tong i-transpose sa kabila, you'll get f prime of c equals the mean value. Okay? So that's one of the proofs of the mean value theorem, taking advantage of the fact na na-prove na natin yung Rolls theorem before. And I think this is a recurring theme in this lecture notes na gumagamit tayo ng mga previous theorems pero on selected functions. So the crux of the theorem, or the beauty of the theorem, is on defining the function d. All right? And then applying Rolls theorem thereon. Okay? So I hope that's okay. Now, the mean value theorem gives rise to two important results. Una, na kaya nating ipakita gamit yung mean value theorem, and I think that's in corollary 4.1, na kapag ka 0 yung derivative, automatic constant yung function. Alam na kasi natin yung unang, yung isang way. Kapag ka meron kang constant function, ang derivative niya lagi ay 0. A nice question is, does the converse also hold? That is, if I have a function whose derivative is equal to 0 all throughout the interval, does that mean that the function is constant over the entire interval? Okay. that is answered in the affirmative in corollary 4.1. In corollary 4.2, we're going to see that kapag ka meron kang dalawang derivatives na equal sa isa't isa over an interval AB, then the functions f and g, okay, so ang assumption mo ang f prime ay equal kay g prime sa buong interval AB, then we are sure that f is g plus some constant, which is basically a result that we usually use in integration. Okay? But first things first, let's look at the first nice result, which is corollary 4.1. Na kapag ka si g ay differentiable on the open interval, then g prime and g prime is 0 for all x in the interval, then g of x must be a constant. Okay? So yun yung gusto nating ipakita. Corollary siya ng mean value theorem. So basically, the main ingredient in the proof should be the mean value theorem. So ito naman yung trick. Kukuha ko ng dalawang arbitrary elements of the interval. Let's call them x and y. Okay? X and y are arbitrarily chosen. Kahit anong elements ng interval I. But without loss of generality, I will assume that x is less than y. Kung baliktad, kung ang y ay less than x, then you can just interchange the roles of x and y. It doesn't matter, all right? Kaya sabi dito, without loss of generality, we can assume this. Because again, otherwise, you'll just interchange their names. Okay. Si g ay differentiable sa open interval, so we can apply MVT. So that means there exists a number c between x and y, which is a subset of I, such that g prime of c is equal to the mean value. Okay? So application ng mean value theorem. Pero dito papasok yung assumption natin na yung derivative ay equal kay 0 sa lahat ng x's doon sa interval I. Si c ay nasa interval I, so g prime of c must be equal to 0. So if g prime of c is equal to 0, then we'll have g of y minus g of x all over y minus x is equal to 0. Multiply both sides by y minus x will give us g of y minus g of x equals 0, or that means g of y is equal to g of x. All right? So si g of y ay equal kay g of x, pero si x at saka si y ay arbitrary members ng I. So x and y can literally be any element of the interval capital I. So ibig sabihin, mafo-force tayo na lahat ng g of y ay equal sa lahat ng g of x, sa lahat ng x at y doon sa open interval I. So we don't have any choice but to accept that g is constant on the interval I. Okay? Kasi nga, totoo ito sa lahat ng x at y, kahit ano pa sila sa interval I. So ibig sabihin, dapat constant all throughout the interval I yung value ni g. Okay? Thus proving corollary 4.1. Okay, so ngayon, sure na tayo na kapag ka ang derivative ay 0, laging constant yung function na yon. Alright? Doon sa interval na given. Okay? Any questions with that? Parang ang dali-dali ng mga proofs, no? Pero kung mag-start ka sa scratch, tapos first time mo makikita yung MVT, first time mo makikita yung corollary, mukhang it will take a lot of time before you can go up with this elegant proof. Pero pag binasa mo yung proof ng Daya, parang ang dali-dali. So, kung ganun yung nararamdaman nyo about the problem sets or any math problem, don't fret, don't worry about it. That's natural. We were all there, okay? Medyo lamang lang siguro kami ng experience sa inyo. Pero yeah, let it simmer. Kung medyo mahirap yung problem, you sat down on it, and then you sat down, try to solve this for a couple of hours, tapos dead end. Take a break. Take a walk, get your mind out of it, manood kayo ng isang episode nung favorite series nyo, tapos balikan nyo siya after some time. so that you come re-energized and you have a fresh mind, and probably you will see the right path, or you can see a path forward into your proof. Okay? So tips na rin para dun sa problem set. I just have a little worry about the problem set, but siguro let's talk about it later. Okay? So if you don't have any reactions about corollary 4.1, I'll assume that everything is fine. Let's look at corollary 4.2. Ito yung result na ginagamit natin usually sa antiderivatives o sa integration, na pag meron tayong dalawang functions f and g, na ang derivative niya ay equal sa isa't isa, then we say that f and g differ only by a constant all throughout the given interval. Okay? So again, dito, ang assumption natin ay equal yung derivative ng dalawang functions f and g. Then the conclusion is that their difference is a constant all throughout the given interval, or that is one function can be represented as a translation of the previous function. Okay? And there's a hint in the proof. Hindi niya na sinulat, pero binigay niya yung hint. I-consider now natin yung f of x minus g of x. All right, let's see what happens if I will consider this. Sige. Kasi usually ayun yung mahirap. Ano yung function na i-consider nyo at a-applyan ng mga previous results. So you need to be a little creative about the choice of these functions. Pero luckily, kasi starter pa lang naman tayo sa 4.2, nagbigay sila ng hint. So kung ito ay totoo, okay? So consider natin siya. Tapos ang assumption natin is something about the derivatives of f and g. So probably it would be fine if I will take the derivative of h. Kasi ang tanging information or assumption lang natin galing sa corollary ay equal yung f prime at saka g prime. So kung nag-consider ako ng h na f minus g, then in order to apply the assumption in the corollary, kunin ko kaya yung derivative ni h. Pero yung derivative ni h ay derivative ni f minus derivative ni g. Okay? Now, what do we know? Well, f prime is equal to g prime for all x in the interval. So this guy will be 0 for all x in the interval by assumption, right? Equal sila all throughout. So dapat ay equal kay 0 yung difference. Okay? So if that is true, then what can we say about h? Anyone? Ano yung pwede kong masabi about the function h? Oy, nagkakahiyaan pa. Oh guys, okay mahiya. Sayang yung points. Yes, Carlo.
Since it's the slope, we can say it's either relative maximum or minimum.
Okay. Yes. Probably here you're saying that this value of x will give you the maximum or minimum of h prime. Kaya lang, totoo siya sa lahat ng x dun sa interval. So, are you saying na lahat ng x ay absolute maximum at absolute minimum doon sa buong interval I? Which is probably right because pero pakabila pala yon, no? Ang Fermat's theorem, dapat alam mo na maximum or minimum. Dapat equal kay 0 yung derivative. But ang alam ko dito, equal kay 0 yung derivative. So probably I cannot say for certain using only Fermat's theorem that x will give me a maximum or a minimum. Nice try though, Carlo. Anyone else? Yes, Ray.
Yung function po is constant since yung derivative po is 0.
Okay, great. That's what I'm looking for. So thank you, Ray. H is a constant function on the interval I kasi yung derivative ni H ay 0 doon sa buong interval I. By one of the results that we have, anong bang result yan? By corollary 4.1, ibig sabihin si H dapat ay constant doon sa interval I. Okay? So that means that is h of x is equal to some constant k for all x in the I. Okay? So dahil si h of x ay equal kay k, so therefore, we'll have k equals f of x minus g of x. And so I can write it as g of x equals, ang gusto ko pala ay f of x equals g of x plus k for all x in I. All right? So end of proof. Okay. Pwedeng mag-work yung suggestion ni Carlo, kaya lang ang problema ron ay hindi natin alam kapag ka zero yung derivative, automatic ba na siya ay maximum or minimum. Alright? So yun yung problema natin doon. Pwede mo siyang ma-argue kasi yung f and g are differentiable, and probably we can also kung may assumption na continuous siya, pwede sana. Kaya lang kulang yung assumptions, kaya hindi ko magamit yung argument ni Carlo. But with appropriate additional assumptions, that can also work. Ang magiging conclusion naman doon ay dahil maximum or minimum lahat ng function values doon sa interval, then dapat yung function h ay constant. Pero again, that will require some more additional assumptions. Okay? But thank you for the suggestions, Carla and Ray. Okay, so that's 4.2, and that's one result that we are using when you did integration in your elementary calculus classes. Okay. Now another of value theorem. Okay, let's see. Here, we consider two functions f and g. So ito naman ay mean value theorem, pero dalawang magkaibang functions yung involved. Same assumption. F and g must be continuous on the closed interval and differentiable on the open interval. Then the promise is that there will exist a number c in the open interval AB such that this equation, let's call this equation star, yung equation star ay totoo. So we can find a number c in the interval AB such that f of b let's see, may mas maganda bang form tong equation na to? Okay. Yeah, I think we'll stick here. The other nicer form for equation star is that we know that g prime is never zero, because if g prime is never zero on the open interval AB, then I can divide both sides by actually yun lang ba yung kailangan? I can divide both sides by g prime, so kaya may g prime dito. Pero what will happen if g of a is equal to g of b? Perhaps we can just say that here under and g of b is not equal to g of a, then we can write equation star as double star. Okay. So para maging kamukha siya at least ng mean value theorem, all right? So yung specific mean value theorem, okay? Tinawag siyang generalized mean value theorem because if we will take g to be the identity function, okay, if g of x is equal to x, then what will we get? Then g prime is equal to 1. So ito ay magiging f prime lamang. So please correct yung statement ng theorem 4.8 pala sa handout na wala yung prime sa ilalim, but that should be g prime in the denominator. Tapos, paano ko mapapalabas si basic MVT mula dito sa GMVT? Well, take g of x equals x, the identity function. So g prime will be 1. Mawawala lang siya. F prime yung magiging left-hand side. And so, if this is the identity function, then g of b is equal to b, and g of a is equal to a. So this guy will be b minus a. So we get back the mean value theorem. Okay? Now, paano natin ipoprove itong GMVT? Now, makiki-ride on ulit tayo sa Rolls Theorem. Pero this time, ito yung clever trick na gagamitin natin. Okay? So we will consider h to be the function f of b minus f of a times g of x minus g of b minus g of a times f of x. Alright? Tingnan natin kung bakit yan yung piniling function na paglaruan. And this is one of the illustrations kaya lagi kong iniisip na, or at least for me, mas mahirap yung proof sa analysis kesa sa algebra. Kasi marami tayong mga functions na kino-consider seemingly out of nowhere. Alright? So nagde-design tayo ng functions, nagko-construct tayo ng sets para mag-suit dun sa purpose natin. Okay? So the hint of theorem 4.8 says, let's consider this function h. You will see later why this function h is chosen. And it says that we just need to apply Rolls Theorem for it. So tingnan natin. Okay. Now, gusto ko ma-apply si Rolls Theorem. Rolls Theorem dapat continuous on the closed, differentiable on the open. But those two things are satisfied by f and g. All right? Si G at saka si F ay parehas continuous on the closed and differentiable on the open. If we scale them by some constant, so si G na multiply lang ng constant f of b minus f of a, si F na multiply lang din ng constant na g of b minus g of a. So these two terms are still differentiable and continuous on the open and closed interval respectively. So their difference will inherit the same property. So we can say that H is continuous on the closed interval and H is open on, is differentiable on the open interval. Okay. Again, na-inherit niya lang ito mula dun sa property ni G at saka ni F. Okay. And then para mag-apply si Rolls Theorem, H of A must be equal to H of B. Well, let's compute H of A. This will be F of B minus F of A times G of A minus G of B minus G of A times F of A. And then this guy will be what? Let's see. So we have a G. Okay, so here I will have a negative F of A times G of A. So that will give us negative F of A, G of A. All right. But here I'll get this and this. Pag minultiply ko siya, magkakaroon ako ng negative G of A times F of A. But it is in the it's in the subtrahend. So I'll have negative, negative. So we will have plus G of A, F of A. So these two guys will cancel each other out, leaving us only with what? Matitira lang ay F of B, G of A, minus, nawala yung GAFA. So naging G of B, F of A lamang. Okay? Ito yung value ni H of A. Similarly, we can compute H of B. H of B is F of A minus, F of B minus F of A times G of B minus G of B minus G of A times F of B. Okay? And then let's see how will it simplify. Well, I have what? Oh, here I have F of B times G of B minus G of B times F of B. So they will cancel each other out, leaving us only with negative F of A, G of B. And then dun sa second, matitira lang ay etong product na to. So that will be negative GAFB. Pero there's a minus sign outside. So it's going to be plus G of B, G of A times F of B. And then this is the same as this guy. And then this is exactly this one. So therefore, we can say that H of A is equal to H of B. Okay? So, kaya pala, ganito yung pinili natin na function h because this function h will satisfy the requirements of Rolls Theorem. Tapos ang kagandahan pa sa kanya, Pag in-apply ko yung Rolls Theorem sa kanya, okay, ganito yung mangyayari. So by Rolls Theorem, there exists a number C on the open interval AB such that H prime of C is equal to 0. Yan yung pangako ng Rolls Theorem. Now, let's compute H prime. Okay. So si H prime of X ay equal lamang kay constant multiplier. So ito pa rin siya. But this time times G prime of X minus G of B minus G of A times the derivative of F. So yan yung derivative niya. Then plug in C. So we'll have H prime of C equals F of B minus F of A times G prime of C minus G of B minus G of A F prime of C. Tapos dito natin makikita bakit out of the many functions involving F and G that we can define or we can tailor fit so that it will satisfy the requirements of the Rolls Theorem, why on earth did we choose to consider this specific function H? Alam lang natin at the number C on the open interval, the derivative will be equal to 0. Pero yung kagandahan ng pagkaka-define dito sa function na to, a simple rearrangement of the equation. So equal siya kay 0. There we go. Ito pala, pwede kong ilipat to sa kabila. Okay. Lagay ko siya dyan. Tapos equal siya dito. Oops. Okay. And basically, this is the conclusion of the general mean value or the generalized mean value theorem. Okay? So kaya ganun yung pagkaka-define dun sa function h. Alright? Kasi in the end, ine-expect natin na kailangan ko si h prime equals 0. Okay? Gusto kong ipakita yung equality. So dapat dapat ilipat ko lang to sa kabila. Okay? Tapos ito dapat ay mag-0. So dapat ito yung function h or yun yung magbibigay sa akin ng function h doon sa Rolls Theorem. Okay? Kaya para nag-work backwards, para mahanap ano dapat yung function na h na gamitin ko para ma-prove yung generalized mean value theorem. Okay? So ganun ka-cunning o ka-clever kayo dapat sa pag-prove sa analysis. So kailangan piliin pilian carefully kung ano yung function na i-consider. Okay? And usually that comes with experience. So kung nagsisimula pa lang kayo sa advanced calc, isipin nyo, mahirap talagang maghanap ng function that will satisfy your needs. But usually that's the way to go in calculus or in advanced calculus or in analysis in general. So yeah, and that will only come with constant practice and a lot of exercise solving. Okay? So any questions so far? I think we just have one theorem left before we close this lecture notes. Okay. Any questions muna? Okay. Kung wala, then let's finish it off by looking at the last result. Of course, marami pang results sa derivatives na probably na-encounter nyo sa elementary calculus, but we will not prove all of them. You can revisit your elementary calculus notes for the proof of some of them. Kaya lang yun nga, medyo technical yung concept ng derivative, so probably there might be some results in elementary calculus na ginagamit na natin, pero hindi pa rin natin kaya silang i-prove with these concepts in advanced calculus. Baka nasa graduate level real analysis pa sila. Okay? But one nice interesting result is L'Hopital's rule. Okay? Na para sa case na 0 over 0. And with the generalized mean value theorem, we can easily prove L'Hopital's rule. Sa Math 36 o sa elementary calculus nyo, yung L'Hopital's rule, binibigay lang siya. Na kapag ka nag-evaluate ka ng limit, okay, nag-evaluate ka ng limit ng isang quotient, okay? Tapos di ba ang sabi, ang turo sa atin pagka nag-evaluate ka ng limit, try direct substitution first because in math, in elementary calculus, almost continuous naman lahat ng functions na kina-consider. So try mong i-plug in yung C doon sa quotient, all right? And if you don't have any problem, then most probably the limit is equal to the quotient of the function values. But there is an exemption when you'll get the case 0 over 0 or infinity over infinity. Yun yung mga cases na covered ng L'Hopital's rule. Hindi natin siya pinuprove kasi ang focus sa Math 36 ay yung application or computational aspects of calculus. But for us now, we can try to prove the L'Hopital's rule, at least for the case na 0 over 0. Okay? And the formal statement of L'Hopital's rule is as follow. Okay. Theorem 4.9. So we consider two continuous functions f and g. Kaya ang turo sa Math 36, plug in nyo yung number kung saan nyo kinukuha yung limit dun sa f over g. Because we are assuming that f and g are both continuous on an interval containing the number a, on which we are evaluating the limit at. Okay. And then we also assume that f and g are differentiable on this interval with the exception of the point A. Now, if it happens that f of A and g of A are both equal to 0, eto na yung nangyari na nag-plug in ka, nakakuha ka ng 0 over 0. Ang sabi ni L'Hopital's rule, kapag ka yung limit ng ratio ng derivatives ay equal sa isang number L, then yung limit ng original ratio ay equal rin kay L. Kaya ang ginagawa natin sa Math 36, kinocompute natin yung limit ng f prime over g prime. Kasi ang sinasabi ni L'Hopital's rule, kung yung limit ng f prime over g prime ay equal kay L, then magfa-follow na yung limit ng f over g ay equal kay L. Okay, so basically, yun yung ginagawa natin sa Math 36. Though nakatago siya doon sa intermediate process, pero technically, ito yung ginagawa natin. Alam kasi natin by L'Hopital's rule na yung limit ng ratio ng derivatives ay equal dun sa limit ng ratio ng functions. Okay, provided meron kang 0 over 0 case. All right? So let's see how it is proven. And it is a combination of the definition of the limit of a function and the generalized mean value theorem. Okay? So again, our assumption here is that the limit of the ratio of the derivatives is equal to L. So ibig sabihin, part to ng assumption. So applying the definition of the limit here, if we are given any epsilon greater than 0, we can find a delta greater than 0 such that function value nung limit, nung kinukunan natin ng limit, so that would be f prime over g prime, minus the supposed limit, pero alam na natin ay limit ay L, etong absolute value na to ay magiging less than kay epsilon whenever the variable t assumes a value within delta distance from A. So nothing fancy here. In-apply lang natin yung definition ng limit dito sa statement na ito. Okay? Now, for this particular delta, dun sa response na delta, pipili ako ng isang number x. Alright? Ano yung condition ko sa number x na yon? Dapat yung number x na satisfy niya, ito. So we can choose x to be a number greater than a or a number less than a. Pero ang usapan dapat yung absolute value ng x minus a ay less than delta. Okay. And we can do that because we know that a is an accumulation point ng interval. Ng interval under consideration. So dahil siya ay limit point, so makakakuha ko ng element ng open interval, say x, na within any distance from A. So however small delta is, we can always find a number x such that this inequality holds. Kaya nating pumili ng element ng interval, mga x's, na sobrang lapit kay A, to the point that they are within delta distance. Okay? And then, since we know that f and g by assumption are continuous and differentiable on the closed and open intervals respectively, then we can apply the generalized mean value theorem to them, on the closed interval a comma x, right? Dito papasok yung consideration na si x ay greater than a. If you have chosen x to be less than a, then you will apply GMVT on x comma a. Not a big deal. Ang sinasabi niya lang ay then there exists a number c between a and x such that this is true. Ito yung conclusion ng mean value theorem. Okay? Now, since c is on the open interval ax, and we said that the length of the interval a comma x is less than delta, all right, then the absolute value of c minus a is still within delta. Okay? And since f prime over g prime is equal to f over g, then we say that f of x minus L is equal to this guy, all right? But we know na ito ay totoo, so papasok siya dito. C minus A is less than delta, so I can replace T here by C. This will be replaced by C, so this will be true. Okay? So napakita natin dito ang f of x over g of x minus L ay less than din kay epsilon. So in summary, what have we shown here? We have shown that for any epsilon greater than 0, there exists a delta greater than 0 such that if c minus a has absolute value strictly between 0 and delta, it follows that f of x over g of x minus L has absolute value less than epsilon. But that is basically the definition ng limit. So therefore, here we can say that the limit of f of x over g of x as x approaches c, or as x approaches a, is equal to L. End of proof. Okay? And that ends lecture notes 4. Okay? Questions, guys? Or kailangan niyo ng time para i-absorb yung mga nangyari today? So I hope that is good. Walang questions? Okay, so that ends this unit. Yun nga pala, holiday nga pala sa Tuesday, November 30th, in observance of Bonifacio Day. So wala tayong pasok, so we'll see each other na lang on Thursday. Pero yung deadline ng problem set nyo ay November 29, no? Okay. So since this would be the last meeting before the deadline, do you guys have some questions about the problem set? May mga request ba kayo dyan or may mga clarificatory questions? Or ito pala muna, na-access nyo na ba yung problem set or hindi pa? Baka yun pala muna yung unang tanong.
Na-access na po, sir.
Kumusta naman?
Mahirap po, sir.
Yun na nga yung fear ko eh. Nung pagka-upload ko, napaisip ko, parang hindi siya ganun ka-level nung problem set 1 and 2. Or probably you'll just need more time para i-simmer yung ideas para sa kanila. Okay. Yes, Carlo?
Sir, question lang sa problem set number 4, yung item number 4. Is it given that the function j is continuous or not? Or hindi siya hypothesis?
Hindi siya part ng hypothesis.
Okay.
Thank
you. Just want to clarify.
Okay, yeah. Inisip ko kailangan ko ba yung continuity or can I skip that or magfa-follow ba siya mula dun sa assumption? Let's see. Yeah, on its face, walang requirement na dapat siya ay continuous. Okay. Now, this function, alam nyo ba yung technical term para dito? Para sa mga function J that satisfies this.
Base research goals periodic function. Is that
Okay,
right?
great. That's correct. So this is an example of a periodic function with period P. Okay. So, yeah, example ng mga functions na to ay sine, cosine, tangent, yung mga trigonometric functions. So, example sila ng mga periodic functions. And dahil periodic sila, uniformly continuous yung sine, cosine, tangent, and cotangent. So, try to prove it on your own. Pero kung nahirapan talaga kayo, you can go to the internet or see some books. Tapos tingnan nyo na search nyo na a periodic function is uniformly continuous. Try to read the proof. Nag-exist na naman yung proofs nila. And I won't shame you for doing that because that's another way of studying and learning. Okay. Basahin yung mga existing proofs and try to write it on your own after reading it. So, or i-paraphrase nyo bawat line. Or kasi ang tendency sa mga books at saka sa mga sites, merong ibibigay nila yung proof pero hindi nila sinusulat lahat ng detalye. So it will be a great thing if you can find a proof online. Tapos if you fill in nyo yung mga details na nawawala. So explanation, may sasabihin silang isang line. It is clear that J has this property. Pero kung hindi obviously clear sa inyo kung bakit merong property na yun si J, try to write it out. Fill in those gaps in the proof and I will greatly appreciate your effort for that. Okay? So, isa yung, kahit ako kahit nito, nung nag-PhD na ako, ganun din. May mga problems na parang out of this world or hindi ko talaga siya ma-prove on my own. But I always see to it na I'll try muna. Nasagutan siya. Parang I'll come to it with a fresh mind without the bias created by looking at somebody else's work. So, tatry ko muna siyang sagutan. I'll try to work it out 1 or 2 hours and then titigilan ko muna siya. Tapos mag-YouTube muna ako. Manonood ako ng something. Tapos babalikan ko uli siya. Pag hindi ko talaga siya makuha, malapit na yung deadline, pupunta na ako sa Math Exchange. Isa-search ko na yung keywords. And then I'll hope that there is a similar proof. If not, kung nandun na yung proof, mas maganda. Tapos I'll just rewrite it on my own. Okay? Kasi with that, ma-appreciate ko rin, ganito pala dapat yung proof. Natuto ako along the way. So yun naman yung goal natin dito. Hindi naman, yung problem sets actually ay dinidesign ko hindi lang para ma-test yung learnings nyo. Pero ang main goal ko talaga sa problem sets ay i-challenge kayo at saka matutunan nyo yung ibang mga concepts na hindi natin talaga diniscuss sa klase. Specifically in the synthesis part, yung una, it is talking about uniform continuity, pero ginamit niya yung konsepto ng pag-limits at infinity na hindi naman natin diniscuss sa klase. So, i-define ko siya dito, nagbigay ako ng bagong definition, tapos i-connect nyo siya dun sa mga konsepto na diniscuss natin sa klase. So, para dito, matututunan nyo yung konsepto ng limits at infinity without me necessarily discussing it in class. Binigay ko lang yung definition dito. So, yeah. And then yung number 6, medyo mas mahaba yung kailangan yung aralin sa number 6 kasi this is talking about absolute continuity. So, kailan absolutely continuous ang isang function? Kapag hindi lamang yung mga function values yung less than epsilon, pero yung summation ng mga absolute value ang magiging less than epsilon provided na yung summation ng mga exabytes na ginamit ay less than delta. Okay? Now, meron siyang assumption non-overlapping intervals dapat. So this is the standard definition of absolute continuity. Then gusto nating ipakita sa problem 6 na kapag siya ay absolutely continuous, then siya ay uniformly continuous dapat. And we haven't encountered absolute continuity in class, but I gave you the definition here, okay? And Yeah, I think kaya niyong ma-prove mula lamang dito sa definition ng absolute continuity na siya ay uniformly continuous din. You need no other result from absolute continuity para ipakita na siya ay uniform continuity other than just the definition of absolute continuity. So ganun yung mangyayari dun sa synthesis part. Okay? Sa part C. Siguro ito yung pinakamahirap na part. But I would love to see how will you perform dito sa problems 5 and 6. So just do your best and yeah, I'll take care of the rest. So tingnan natin. I would just like to challenge you at this problem set. Okay? What do you think about the deadline? Can you do it on December 1st? Sorry, hindi pala. Ang deadline pala natin ay November 29th. So 3 problems lang naman. What do you think, guys? Do you need more time for it? Or okay na yung this November 29th? Okay, wala nagre-react? Or nagkakahiyaan lang ba?
Sir, December 1 na po.
Nakakainis, nadulas ako.
Second
Kasi,
the motion po, sir. Second the motion.
nakakainis, nadulas ako. Kasi December 1 yung deadline nung yung pa-problem set ko sa Math 101. Yun yung nabasa ko dito sa kodigo ko. Pero, December 1? Okay, sige. Gusto ko sana mag-check na ako ng November 30, pero sige, December 1 yung deadline. So, upon motion, may objections pala muna.
No objections po, sir.
Andaya, ikaw na yung nag-second the motion eh. Tapos no objection. So, yeah, I think nobody will object kasi kung gusto niyo siyang tapusin bago yung holiday, so nobody's preventing you from submitting it early. So, since it was moved and duly seconded and there are no objections, so therefore let's move the deadline for problem set number 3 to December 1, right before midnight. Okay? Ano yung December 1? Ang December 1 ay December 1 is on a Wednesday. Okay, that's fine. And then on December 2, we will start with the last chapter. So for Math 155. Okay? So siya naman ay tungkol sa integration and that will be our topic until the end of the semester. Okay? Sige, hindi ko na muna rin kayo bibigyan ng homework next week para makapag-focus pa rin kayo on a good chunk sa problem set. But probably I'll give you a homework. Hindi, bibigay ko siya siguro ng December 3 yung homework. And then papapasa ko siya sa December 10. Homework siya about derivatives. Okay, isang item lang naman, mabilisang item para may at least isang homework tayo sa derivatives. Tapos isang homework sa Unit 4, sa Unit 5. Tapos problem set tayo ng Units 4 and 5. Yun yung problem set number 4. Okay. So yun pala, siguro dahil nandito na rin naman tayo, tapos may 4 minutes pa naman. Hanggang kailan ng SEM? Ang last day ng SEM ay December, let me see if I have a copy of that here. Tandaan nyo ba, kailan ang end ng SEM?
21 po, sir, ang alam ko.
Yeah, tama. December 21. So, kailan nga bang sinabi natin na deadline? Ang problem set 4 ay December 21 ko daw ibibigay. Tapos, ang deadline ay, okay pa rin ba itong deadline na to sa inyo? Kaya lang holiday, ayoko sana mag-work kayo over the holiday kasi that's your time to spend with your family. Pero siguro, okay, so probably I'll give the problem set on December, let's see, December 17. Sige, bigay ko siya ng December 16. Okay, December 16. Then, sige, if I follow ba? ang deadline ay habang before kayong sumubo ng Noche Buena. So December 24, 11:59 p.m. But again, this is just to stretch the deadline. I don't supposedly the deadline would be December 20, the last day of classes. So kung ayaw nyo mag-work over the holidays, so submit it on December 21. That would be the deadline on paper, okay? Pero tatanggap ako ng submission until December 24. Pero again, kung gusto nyo matapos before yung break, so that's December 16, 17, 19, 20, and 21. You will have 6 days for problem set 4. Probably 3 items lang siya uli. So 2 days per item. You should be good. Pero kasi baka marami rin kayong requirements on that week. Sige, papayag ako hanggang December 24 yung deadline. Okay? And then the final exam would be on December, the earliest would be January 7, siya yung final exam. Wala tayong exemption. Lahat kayo ay required na gumawa ng final exam. The deadline would be on the final exam day. Pero siguro ibibigay ko na rin siya sa December 21. So yung final exam nyo, ibibigay ko na ng December 21. Ang earliest deadline ay January 7. Yung actual deadline niya ay kung kailan nakaschedule ang Math 155 na finals doon sa schedule ng registrar. Okay? But I'll give it to you as early as December 17th para kung may free time kayo or na-bore kayo during the holiday break, pwede nyo na siyang masimulan, tas ipasa nyo siya sa Canvas as soon as matapos nyo siya para at least makikita nyo na yung final grade nyo before the finals week. Okay, sa katulong na rin sa akin na kung makapagpasa kayo ng maaga, mas mabilis ko siyang ma-checkan. Okay lang ba yon? So again, optional yung pag-work sa bakasyon, and I encourage you not to work on during the vacation. So try to finish everything before the vacation break. But if the vacation break is the only time that you can work on it full time, and then papayagan ko kayo. Pero hindi yun sa pilitan. And then yung final exam naman, it is doable in 1 day. I guarantee that it is doable 1 or 2 days. So pwedeng antayin nyo na yung tapos ng break. So January 5, babalik na kayo supposedly. Tapos you will have a couple days. January 7 would be the earliest deadline. So you are still fine. Pero kung na-board talaga kayo sa bakasyon, then gawin nyo na siya as early as possible. Okay, but the earliest deadline is January 7. Okay? Yes, and I think that's it. We're set for the rest of the semester. Okay? Any questions or may mga pahabol pa ba kayong requests? Okay, so if there are none, thank you guys for joining me till the end and the end of today's discussion. And enjoy the rest of the night. Enjoy your weekends, and let's see each other again on Thursday next week. Bye, guys.
Thank you.
All right.
Salamat